dear students, today we are going to discuss about section formula. So what is section formula and where we can use this section formula? Suppose we have 2 points, first point A and second point B, and line joining the point A and B is divided by the point C in the ratio of m1 is to m2. So here if you want to find out the coordinate of point C, that is value of x and y, so here we can use this section formula. So first of all, let's see the derivation of section formula, and then we will do some practice problems based on section formula. So first of all, let's see the derivation of section formula. Here we have x coordinate and y coordinate, and the point A and B is divided by point C in the ratio of m1 is to m2. So here if you want to find out the value of x and y, then we can use this section formula. So first of all, let's derive the formula. Here this point A is at the distance of x1 from x-axis. Same with the point C is at the distance of x from the x-axis, and point B is at the distance of x2 from the x-axis. Now draw one horizontal line from point A and one vertical line from point C, and same way one horizontal line from point C and one vertical line from point B, and wherever those two lines intersect, let's say this is point D and this is point E. So here we get two triangles. First triangle ADC and another triangle BCE. Two right angle triangle we have. Now if you want to find out the base of the triangle, base of this first triangle, that is AD. So how will you find out the base of this AD? So you can see here this point D is at the distance of x from x-axis, and point A is at the distance of x1. So this distance AD will be equal to x minus x1, and same way if you want to find out the distance of CE, so point E is at the distance of x2 and point C is at the distance of x. So CE will be equal to x2 minus x1. So here we can write AD is equal to x minus x1 and CE is equal to x2 minus x. Now if you consider those two triangles, triangle ADC and triangle BEC. This is the first triangle ADC and this is the second triangle BEC. So if you observe here, both have one angle of 90 degree. Then here this angle CAD will be equal to the angle BCE, because those two angles are said to be corresponding angles. So those two angles are equal. And if the two angles of any triangles are equal, then we can say the third angle will also equal. So here we can say this angle B and angle C will also equal to each other. So we can say that angle ADC will be similar to triangle CEB using angle rule. And we know that if any two triangles are similar to each other, then the ratio of their corresponding side will be equal. Whenever two triangles are similar to each other, then ratio of their corresponding side will be equal. So here we can say this ratio of this side AD and CE will be equal to ratio of this side AC and CB. So here we can write AD divided by CE will be equal to AC divided by CB. And here we know that value of AD is x minus x1, CE is equal to x2 minus x, AC is equal to m1, and CB is equal to m2. So here if you put the value, AD is x minus x1, CE is x2 minus x, AC is equal to m1, and CB is equal to m2. So here we get one equation. And if you simplify this equation, then here we can find out the value of x. So let's solve this equation. Let me write this equation in next page. This is our equation. Now if you want to find out the value of x, then do the cross multiplication. This m2 will multiply with this x minus x1, and this x2 minus x will be multiplied with m1. So here we get m2 multiplied x minus x1 is equal to m1 multiplied x2 minus x. Now if you multiply this m2 into the bracket, so here we will get m2x minus m2x1 is equal to here m1x2 minus m1x. Now here we wish to find out the value of x. So on rearranging this equation, put this m1x into the left hand side, so it becomes plus m1x. This is m1x2 here, and if you put this m2x1 to the right hand side, then it becomes plus m2x1. Now here we can take this x common from both of this, so remaining is m2 plus m1 is equal to your m1x2 plus m2x1. So here we will find out the value of x. So x equal to m1x2 plus m2x1 divided by m1 plus m2. So this is how we find out the x coordinate. And same way we can find out the y coordinate. So y coordinate will be equal to m1 y2 plus m2 y1 divided by m1 plus m2. So these two formula are known as section formula. So here we get the formula for x, that is equal to m1 x2 plus m2 x1 divided by m1 plus m2. Now here if you divide the denominator and numerator with m2, so let's see what happens if you divide this denominator and numerator both with m2. So here we will get m1 x2 divided by m2. Here if you divide with m2, then m2 will be cancelled out, so we'll get x1. Here m1 divided by m2 plus here m2 will be cancelled out, so we'll get 1. Now in place of m1 by m2, write the k. So we get the another formula for x, that is equal to here in place of m1 by m2 we'll write k. So the formula is kx2 plus x1 divided by k plus 1. And similarly we can write the formula for y. The formula for y will be equal to ky2 plus y1 divided by k plus 1. So this is the another section formula. Suppose if the line A and B is divided by point C in the ratio of k is to 1. So here we can use this formula. X equal to kx2 plus x1 divided by k plus 1 and y equal to ky2 plus y1 divided by k plus 1. Now see the another formula that is derived from section formula. That formula is known as midpoint formula. Suppose we have 2 points, point A and point B, and line joining these 2 points is divided by point C in 2 equal parts. Means point C is the midpoint of point A and B. And if you want to find out the value of this coordinate x and y, so here we can use the midpoint formula, and we can derive the midpoint formula by using section formula. Since C is the midpoint, so we can say the ratio in which this point C divides the line AB will be equal to 1 is to 1. So here we can take m1 equal to 1 and m2 is also equal to 1. Now if you want to find out the value of x, then we can use the section formula for x, that is m1 x2 plus m2 x1 divided by m1 plus m2. Here in place of m1 and m2 we will put 1. So here in place of m1 and m2 we replace with 1. And if you simplify this, then you will get the value of x. So x equal to x2 plus x1 divided by 2. And similarly, if you do the same process for y, you will get the formula for y equal to y2 plus y1 divided by 2. So whenever you want to find out the midpoint of any line, we can use this midpoint formula directly. So in this lecture, we have seen the derivation of section formula and derivation of midpoint formula. In the next lecture, we will solve the problems based on the section formula and midpoint formula. You can see the next video by clicking on the I button here. Thank you and have a nice day.